In the past 10 years, Alcond has been researching 3D bioprinting. Through a current breakthrough, we have now obtained the leading core technology. 3D bioprinting is a robotic system that facilitates the fabrication of three-dimensional cellular structures by placing cellular aggregates called spheroids in a collagen matrix according to pre-designed data. With this method, spheroids are cultured with tens of thousands of cells. Then they are placed in a collagen matrix and allowed to merge with adjacent spheroids to form a connected structure. They can be positioned in any three-dimensional layout. Finally, culturing the connected cellular spheroids promotes the self-organization of cells and yields a three-dimensional product with the desired function of the original organ or tissue. The 3D bioprinting process works by first loading a syringe-based deposition system with a biologically active gel containing between 2 and 20 million chondrocyte cells per milliliter, together with an alginate, hyaluronic acid growth factor beta-1, antibiotics, and gelatin. A control software, which is based on a printer-face architecture, is used to instruct stepper motors attached to each axis to position the head in X, Y, or Z coordinates. This process allows for the fabrication of a tissue structure to a plus or minus 5 micron-meter degree of precision. As the tissue is bioprinted, the deposition speed is altered in situ to ensure that the tissue resolution is maintained. The bioprinted pre-tissue is then transferred to a 37.8 degrees Celsius bioreactor. Growth factor is replaced every 2 days and cells begin to grow and mature into a tissue matrix over a period of 3 weeks. Then, 0.1% hyaluronic acid is added to the biogel to limit the loss of proteoglycans during tissue maturation. This is important as proteoglycans are a critical component of extracellular matrices. This filler material exists between the cells of tissues and makes up the structural and biochemical support to the surrounding tissue. Without it, a tissue would not form correctly. 3D bioprinting research at Alcond focuses on building simple living tissues for use in this type of reconstructive surgery to directly benefit these patients. We are currently researching the technology to make biological structures that can be used to replace damaged or lost cartilage in the knee. The global knee replacement market was worth $6.9 billion in 2010, and due to our aging population, it is estimated to reach $11 billion by 2017. In the long term, the ultimate aim of this research is to develop bioprinting as a process that can be used to produce multiple types of tissue, to act as operative repair materials, or to be used in the short term for pharmaceutical testing. With further engineering work, we can enable the simultaneous deposition of different cell types, including stromal stem cells, cardiomyocytes, progenitor cells, osteoblasts, and osteocytes to produce complex tissues. Stem cell-based materials can also be deposited to produce complex tissue structures for such applications as abdominal, breast, ear, tracheal, and nose reconstructive surgeries for cancer patients or burn victims. We hope someday to be able to print fully functional human eyes. Today, Alcond is commercializing breakthroughs in skeletal reconstruction, skin regeneration, and blood vessel and organ reconstruction technologies. Alcond is already a leader in 3D bioprinting. We hope to bring this game-changing technology to better the world.